Welcome to Making Stuff with Chris Dayhut and This Maker's Tools. For today's topic of discussion, we're going to be taking a look at cordless drill drivers and answering the questions, should you have one? Cordless power tools, often referred to as drill drivers, are a motorized device that rotates a tool often with a drill bit, for the purpose of drilling holes and for doing many other tasks beyond drilling. They are equally exceptional at drilling holes and driving fasteners and many other tasks. The history of drilling, there's a little bit of debate with the historians and intellectuals about how far back in time we've been drilling holes. One reference shows that it was about 3000 BC, meaning about 5,000 years ago. The other reference that I found was taking us back 35,000 years. So we'll just say we've been drilling holes for a long time as humans. In 1813, Richard Trevithick designed the first steam-driven rotary drill. And most likely that was a beast of a machine and a nightmare to operate, and I highly doubt I would consider it portable. In 1889, Arnott and Bryan developed the first electric drill. The German company C.E. Fine invented the first portable handheld drill in 1895. So now we're starting to get into what our modern view of a portable drill is. In 1917, Black & Decker patented the pistol grip trigger switch design, which really revolutionized drill portability and ease of use. And that's really the format that we're still using to this day. In 1961, which by the way, not only is the date, but also the manufacturer in debate, the first cordless drill was introduced. 1978, Makita released the first cordless drill with a removable battery. Again, now we're fitting that modern day and current format for a portable handheld drill driver. In 2005, Milwaukee introduced lithium-ion batteries to the cordless drill and as their power supply, and that significantly improved cordless drill designs. Now, just as a quick side note on that, here on the bench I've got two of my still functional cordless drill drivers. This Porter cable is approximately 20 years old, and it's running on an 18-volt NiCad battery. This is a 20-volt lithium-ion battery. Notice the difference in size. I can assure you the weight is different, the bulk is different, and the charge or runtime is much better with the lithium ion. So that's been a great evolution in making portable hand tools so much better. There are many manufacturers of portable hand tools, especially in this arena of drill drivers. Here are some of the most common or most popular brands. DeWalt, RYOBI, Makita, Bosch, Milwaukee, Metabo, and Black & Decker is still around in various forms. All of these have been great contributors to the evolution of portable drill drivers. As with everything these days, it seems like the cost to purchase or the cost to own something has a very, very wide range, and cordless drill drivers are no exception. I did a quick search today to see if I could find out of the local retailers the most expensive and least expensive drill drivers out there. And I found a brand name Autocraft sold by Menards, a home center type retail outlet. It's 12-volt cordless 3/8 drill kit, meaning it's got a charger, a battery, and the drill motor for $8.89. Now, I don't know if I would really put that into my tool collection, but I am really curious to see what you get for that price tag. On the high end, the most expensive tool I could find was from Makita. It's the 40 volt max XGT compact brushless cordless half-inch drill driver kit. Again, it would have battery, charger, and the drill driver motor as well. And that was listed at $419. Now, to be fair with the one that was at $8.89, it's currently on sale this week for $10 off. So normally it's $18.89. The next question may arise, who would actually use them or need them? You would be very surprised if you are unaware of how many people use them and need them. Here are just a few industries where you'll find them used in many applications. There's machinists, mechanics, carpenters, woodworkers, electricians, metal workers, model makers, DIYers of all types doing everything around their homes, and that's just to name a few. Of course, a lot of these are contractors or professional tradesmen. Others are just hobbyists, etc. But my goodness, there are a tremendous amount of cordless drill drivers that are out there. I did a search to try to find out how many were sold in a given period of time, and I went for about a 10-year look. Couldn't find any factual data at all. But I did find this interesting piece of data. The cordless global, this is global, cordless drill market was valued at just under $4 billion in 2022. And that is projected to reach $7 billion within 10 years, growing at an 8% CAGR. So the market is still ever expanding, and more people are buying and using these tools for more applications. Now let's take a look at the features that are found on all of these cordless drill drivers. There are more features available, and if you look at battery capacity as a feature, that also could be considered in this, but I'm trying to stick with what I know were standard size batteries delivered with the tool when I purchased it. The Porter cable is my oldest one, 20 years old, still works great. Even the battery is still working, but it's an NiCad, and they typically had a long lifespan, perhaps more so than lithium ion. Well, it's 20 years old. Trying to get a lithium ion to last past 5 or 6 years is a challenge sometimes. But this has served me very well. Let's look at the normal layout, trigger grip, or pistol grip as we call it, and you squeeze your trigger for making it turn on. And it's variable speed. The further I press in the trigger, the faster it goes. Very conveniently, a great feature is the forward and reverse switch. So I can switch between forward and reverse very easily one-handed by pressing that button in. So that works out very nice. It's a very nice feature. It's convenience. It is a keyless chuck. Earlier chucks off of the original Jacobs type chuck design required a key, and that key you would rotate it to tighten and loosen it. Oddly, even with that key, these new modern chucks tighten more securely on your drills and bits. And to loosen it, you roll it backwards and pull the tool out, or the drill, a reamer, whatever you've got in there. You rotate it forward and tighten it. And the spindle automatically locks so it won't rotate while you're tightening it. So the modern keyless chucks are a great feature today. Another feature is most of them have a dial at the end of the nose of the drill, just before it enters into the body, with a clutch setting. And they're on different scales. Some are 1 to 20, some are 1 to 10, etc. This one, if we look at it on top, it goes to 15 at max, and then it rolls back over to drill mode. Now this clutch setting sets the amount of torque that will pass through the clutch for driving tools. And when we get out to the shop, I'll be demonstrating that there. But I've got it set on setting 1. If I hold on to the chuck and prevent it from rotating, you'll hear it just slipping in the clutch. And it doesn't take a whole lot of force to stop it on setting 1. So you can rotate the dial all the way up to 15, and you'll see I can barely hold on to it. In fact, it just rotates and spins in my hand. I can't stop it from rotating. Then, finally, you would have your drill mode setting where this clutch should not be slipping at all. So it'll have a massive amount of torque going through it. That is a very handy setting. It's tricky for some people to get used to using it, and some people learn how to use the tool with never ever changing it, always leaving it in drill mode. It's just how you work with the tool and use its features to help you and use the feel of the tool while you're operating it. Another really great feature on a lot of these cordless drill driver devices, are 2-speed gear sets. So in setting number 1, it would be a lower max RPM but much higher torque. Setting 2 would be a higher RPM but a lower torque output. Very, very helpful, very beneficial, and making it work exceptionally well as both a drill and a driver type device. You can often get accessories for clips and so forth that can hook onto your belt. Unfortunately for a lot of people, such as myself, if I clip that on my belt, it'll pull my pants down, so I don't do that anymore. But that's the range of features, and you may also see on some battery packs or on some of the systems, they'll have a power level indicator, basically the charge remaining in the battery. So that gives you a good idea of everything that the tool has, the features it has, what it offers, and how they help you do your work with the tool efficiently. As you would suspect, a drill like this has very many different applications. And because it can hold a variety of different size tools, it can also use a lot of different types of tools. As long as the tool rotates, this device, the drill driver, can help you use it far more efficiently. In this case, of course, its primary purpose is for drilling. In this case, I'm showing a 1/2 inch or about a 13 millimeter drill bit, and this baby will power through anything with that size drill. One of the other things that I often do, and this one's too big to fit in this particular chuck, but it was big enough for you to see what it is on camera. This is a large tap. You can do an awful lot of tapping with a drill driver. For a workable range to tap steel, you could probably go as small as 256 or 1.5 millimeters, and up to, say, 3/8 of an inch, which is about 11 millimeters, and maybe even a little bit further, depending on the actual drill driver you're using. Some have more torque. Of course, the two most common being drilling and driving. So if I've got a drive bit in the chuck, I can drill in all sorts of screws, and thank goodness the manufacturers are coming up with replacements for the old Phillips drive, and we're seeing more and more Torx drives, which allow for much better driving force and speed. But these work great for driving, both with driver type bits like this, Torx, flathead, Phillips, etc. But you can also put sockets in here with an adapter and drive socket head or hex head cap screws. You may be wanting to do sanding. These types of sanding drums allow you to sand the edge of material. Very, very handy. Works great. People have been using this process for many, many years. And of course, there's the more modern equivalent. This is a nylon bristle type brush, but it does do a form of sanding and deburring. There are also sandpaper discs that are this large. They're a flapper type wheel, so you can do a lot of sanding and metal conditioning operations with your drill motor, including wire brushing. Wire brushing has been done with drill motors for a very, very long time, so feel free to use it for wire brushing. Chamfering holes. This type of bit puts a chamfer at the entrance or exit of a hole that you may have drilled. Great application for deburring it and making your drilled hole look nice as opposed to all jaggedy. Another application would be to do reaming. Reaming is a way to make a drilled hole more precise in diameter, straighter, and have a better finish. And that's what a reamer would look like. In this case, it's a straight flute reamer. And of course, you can do polishing, waxing your car, all sorts of things with these cordless drills. With that, let's go out to the shop and I'll show you some basic operations such as drilling, tapping, and chamfering holes. Let's go through a few simple tasks on using our cordless drill driver so that you get an idea how simple it is to use, and perhaps you'll see how useful it is as well. Now we'll go through, drill a 3/8 inch diameter hole through this hard maple. Again, load the tool in the chuck, tighten it securely. I would want to be in high speed as I was with the brushing. You want to make sure that when you're drilling, you don't drill into the work surface underneath, that your work piece is securely clamped to some device so it can't move on you, because trust me, it's very easy to start drilling into this. The drill can grab into the wood and start spinning that whole thing around. It's going to be very dangerous if you do that. So securely hold your work. Again, line up as accurately as you can by view your angle. With that, and you heard the clutch slip. I only had the clutch setting at 8, so I would have expected that. Had I turned it all the way to the drill mode, the clutch would not have slipped. And as you can see, we've got a nice clean hole through the part. Because this is hardwood and we're driving these screws in close to the edge, it will want to split apart. So to prevent that, or try to prevent it, I'm going to pre-drill the holes with this drill countersink combination tool. That's just like drilling any other, or doing any other drilling operation. So we'll want the clutch set in drill mode and the speed set at high. And we'll go in, try to do our best to keep everything aligned, and drill straight into the part. Now I'll switch over to using the driver bit, in this case a number 2 Phillips, which is the right size for these screws. I will set my clutch down to, we'll start out at 9. And I want my gear ratio set to the high torque setting, which is number 1. Take our first screw, we'll drive it in. I'm just gonna line up the best I can vertical, just like we do with all drilling operations. I'll slowly start the screw and steadily increase speed. On this next hole, I'll change the clutch setting to 11. And finally, I'll change it to 15 for our final screw. And I kind of got a hunch that screw actually snapped in half. And that is the power of this tool. I snapped the screw off. So what I'm going to do try a slightly different screw and see if I can't get a little better performance out of it. So I'll go with another hole next to it because there's a broken off screw in that one. I've got a longer screw this time, but more importantly, these are typically a tougher screw. So we'll try it again and see what happens. Okay, didn't break off. We got a good screw. But now let's look at how this looks up close. Now you'll see that that screw is standing proud of the wood surface. This screw is almost flush, and that screw is recessed. And that had to do with starting out with a low torque setting, a higher torque setting, and then finally the highest torque setting so that the screw would sink itself into the wood. You'll notice that the hole has a burr in it and a sharp edge, and it really looks unsightly. If I use this tool, a chamfer tool, I can put it in that hole, it'll spin, and I can put a nice chamfer on that surface. Load up my chamfering tool, tighten the collet. I want to be in low speed. I don't have to worry about the torque setting on it, as this operation's very quick and very simple and doesn't require a lot of force. And again, I want to be nice in line with that hole and not off at some crazy angle. Now the hole looks much nicer with that chamfer. Now this particular piece has already been deburred on these outer sections, but I could also wire brush that with my drill driver. For this particular tool, we'll load it in the chuck, tighten it up securely, and I want to be in high speed mode. If you find that it's kind of hard to hold on to and guide, turn your torque setting down, and then that way it'll slip instead of trying to push you away. And with that, you've deburred the edges nicely so there aren't sharp edges. What I'm going to demonstrate now is tapping with my drill driver. This is a process I do very frequently. So I'm going to get the taps securely tight in the chuck. I'm going to be in the lower gear range, number 1. I'll set my torque setting at about 11 and see how that behaves. If it stalls out, I can always turn it up a little bit more. Now this workpiece that I'm going to tap is what's called 80-20 extruded aluminum. There's a hole already extruded into it when it was manufactured to accept a 1/4" 20 tap. So we could tap holes in it, and that way you can use it as a pipe. I'll apply a small amount of tapping fluid, and then I'm going to line up. And at this point, I have to be very careful that I'm not tilted away this way or toward you like the camera, this way or this way. I have to get it as perfectly aligned vertically as I can over that hole. I'll go in as far as I want to, stop it, reverse the spindle, and back it out. Hopefully that gives you a pretty good idea how to use this tool in a variety of applications. As you can see, the cordless drill driver is a very capable, universal, and very handy tool to have. So to answer the question, should you have one? Perhaps I should rephrase that question. You don't have one? To me, I couldn't imagine doing anything around the house, any of my jobs, tasks, construction repairs, without it. In my electronics lab, I use it. In fact, that's where this one resides most of the time, is in the electronics lab. For woodworking, for working on my car, every single thing, building the shed out in the backyard. This tool gets used constantly. So in truth, if you're into hobbies and DIY and tinkering and all sorts of stuff like that, it really is a must-have tool and should be definitely on your Christmas wish list if you don't have one yet. With that, I think we'll wrap up this episode. It's run plenty long already. Thanks for watching, and I look forward to seeing you next time.